I'm cooking something up for you again today. And let me show it to you. Okay, here we go. Ladies and gentlemen, our brand new AI computer. Look at this. I think I might have cooked it a little bit too long. It shrunk.
Hey, is this baked? It's a little bit hard. Hopefully it works good. So for the first project, let's do this, the NanoOwl, which is in their tutorial page, right? And basically the instructions are here, but there are some changes. Basically you have to run this as root, and there are some packages that are missing, and for that you basically add a user, add the required packages, add the necessary permissions for video, and after that it works, right? I will have those details in the description if you're interested. So this is the project. So once I got that fixed, it's working, so you can see. So I'm just using the USB Logitech camera. Let me move this away so you can still see. All right, now it works. Now I can type for something like a face. Yeah, it's able to detect. There's a fan behind me. A fan. No, it's not detecting a fan. Oh yeah, now it's detecting. Okay, let's do within a face. Let's say glasses. Yeah, it's able to detect all that. So all is good. I'll move on to the next project, which is the voice project, and for that I need a microphone. I'll see you there. Okay, the reason I'm showing this RAG search on blog is because the voice is going to be actually calling the search endpoint and doing a query. So whatever comes from the voice is going to be in the query. So that's how it's designed. You can have your own project, but it has to have this this endpoint and this way of querying. So the blogs I'm going to be searching are these 2-minute AI, and the other one is 2-minute security. So I'm going to be asking basically about rate limiting here, and in AI I'm going to be asking about back propagation and maybe transfer learning. Now let's go to the demo. So for that you need a USB microphone. Anything would do. I'm using Fine, and I'm using a USB speaker as well, which is like Jeko. All right, let's get started. Everything runs as containers, including the RAG search, which uses the PG vector. So after warm up, you can do the converse. What is back propagation? All right, now it's thinking. So all the text that comes back from the search API, it needs to kind of make sense out of it and give the response. It's going to take a while.
Backpropagation is a method used for training neural network models by estimating the gradient of the loss function with respect to the network's weights. It helps in adjusting internal parameters to minimize differences between predicted and actual results, much like how players learn from failures in video games or improve through repeated...
Yeah, this is exactly what is in the blog. What's the source of backpropagation? Let's see if it's able to find the source.
The source provided is an article titled Learning Through Failure, Parallels of Backpropagation, Neural Networks, and Philosophy by Tu Minai. The article discusses how backpropagation works in neural networks to estimate gradients for weight adjustments, drawing parallels between this technique and the iterative learning process in video games, and philosophical concepts like Samuel Beckett's quote about failure being part of improvement.
What about rate limiting? It takes a while because the model is a small model. takes a while to make sense of all the text and give the details. And I can also show the search. Here you can see the search that's happening with that. Right, so you can see all the queries that it
Rate limiting is a security measure that helps protect APIs from attacks like DDoS denial of service and DDoS distributed denial of service. It prevents attackers from overwhelming the server with requests, causing resource exhaustion or system crashes. Proper implementation can also help prevent brute force attacks on authentication endpoints and reduce the attack surface by limiting access to services. Rate limits can be configured based on various criteria such as source, destination, and protocol, providing fine-grained control over traffic management. Kubernetes service meshes like Istio offer built-in support for rate limiting and circuit breaking, making it easier to implement in microservices environments.
What's the source of rate limiting? So I provided the URL as part of the JSON. Sometimes it uses that, sometimes it just gives the title. Let's see what it comes up with now.
The source of rate limiting in Kubernetes, as demonstrated by the provided context, is Istio. The text mentions that Istio provides built-in support for both rate limiting and circuit breaking, which are essential components for implementing proper rate limiting policies. Istio can be used to address security concerns described in the context, such as denial of service DDoS attacks, brute force attacks, and credential stuffing.
Do you have the URL for rate limiting? Let's see if it gets the URL this time. And what it's saying is correct. I just, the blog has just rate limit with Istio, not the other ones.
Yes, I do have a link provided for rate limiting. You can find it here. Source: https://2minsecurity.blogspot.com/2024/08/rate limiting in Kubernetes using istio.html.
All right, hopefully you found this useful. I'll share this project and you can change the search endpoint to implement one on your own. Hopefully you found it useful. Like, subscribe if you found it useful. Thank you so much.